So today we're going to look at a second part to this set of lessons with, we did some simple solving just to look up the angles. And we did a little bit with solving before that, but now we're going to get a lot more in depth on inverse operations. And I'm going to show you the substitution method for this because I think this will help you tremendously. If you feel like you don't need this substitution method, you don't have to do it. But a lot of times students get so hung up on the fact that when you look at this question, you've got the sine of theta in there, and they can't see the forest for the trees, so to speak, because they can't figure out what to do because there's a sine of theta in there. So I'm going to suggest that you take that out and put an x in its place and solve your problem for x first. So we know that if we were solving this for x, that we would take away 3, and we would divide by 2. Once you get it down to that point where you know what x is, go back and substitute back the sine of theta for your x. And work that just like we did in the previous lessons when we started this chapter. Where is sine negative 1/2? But now, instead of focusing on certain quadrants, you can use the whole unit circle. So when I want to inverse this, I want all possible solutions. So I first go to the unit circle and realize that sine is negative in quadrant 3 and 4. And sine is 1/2 in the point when it's negative, right there at 11 pi over 6 and 7 pi over 6. Now I don't need to change these to beta angles because I'm using the whole unit circle now. And so my answer is 7 pi over 6 and 11 pi over 6. And because I don't want to go past 2 pi, I don't have to do that thing we did on the first part of this lesson where I add 2 pi to get 6 answers. Alright, so in number 2, if I take out the trig, then it would say 4x equals 1. Well, wait a minute, we need to rewrite this. I just realized there's a square in this problem. That needs to be written different. So what this really means is 4 cosine of theta quantity squared equals 1. So if I take out what's in the parentheses, I will be taking out the trig. So that will be 4x squared equals 1. And I know how to solve that. So I will divide by 4 and get x squared equals 1/4. And square root it, which means square root each individual piece. Now remember, when you solve by hand on square roots, you always get plus or minus answers. And so I'm looking for plus or minus 1/2. So now I'm looking for where's the cosine of theta equal to 1/2, and where's the cosine of theta equal to negative 1/2. And so I'll go to my unit circle and think about the fact that cosine is positive on the top and negative at the, note that sign. It's positive on 1 and 4 and negative on 2 and 3. So it's going to have an answer in each quadrant. But the half line is ones that's on the thirds because it's at the top to be close to the 0 at pi over 2. So I have pi over 3, 2 pi over 3, 4 pi over 3, and 5 pi over 3 because that's the ones that have either a positive or a negative cosine as 1/2 because the first number is 1/2. I can get my board to switch. There we go. Next, let's look at what if trig's all you've got? Because see, that's all inside. This is all inside my trig. Well, then you need to start with inversing. And let me show you something about this inversing. I keep trying to reiterate this. You're inversing both sides. You really are doing inverse to both sides. When you change a problem to theta equals, you're inversing both sides. And what that does is it drops off the cosines on this side because we know we're going to be in the right quadrant because we're going to look up the right quadrant, and that leaves me with 2 theta. This side, we got to figure out where cosine's negative and pick up that answer. We just had that answer on the previous question, thank goodness, so I don't have to really think again. Cosine's negative in 2 and 3, and for it to be negative 1/2 in the first position, it would have to be 2 pi over 3 and 4 pi over 3. So we set up a problem equal to 2 pi over 3, and we set up a problem equal to 4 pi over 3, and finished solving the inside of the trig, which says 2 theta. So I'm trying to figure out what angle did I double to get 2 pi over 3. And so I'm just flipping and multiplying, just like we've been doing with our half and double angles. I'm just doing the opposite to each one. So the 2's cancel on this one, and the angle before it was doubled is pi over 3. And on this one, 2 goes into 4 2 times, so the angle is 2 pi over 3. So in that particular case, I didn't have to use a double angle formula to work this question, although I could have. But I definitely wanted to think about 2 theta is what makes it come out to be 2 pi over 3 or 4 pi over 3. So let's do one with one of the other words. How do you deal with it if it's secant? Well, the first thing you do is you change it to cosine by flipping the other side. Then you can do cosine inverse to both sides. See, cosine's a whole lot easier to work with than, well, it seems like I keep picking everything's based on a half. Hopefully in a minute we'll have a problem it's not based on a half. So these cancel, give me 3 theta over 2 equals, and again, it happens to be the same two numbers, 2 pi over 3, and 3 theta over 2 equals 4 pi over 3. And don't think it's those same ones all the time. It just happens to be I picked a lot of problems that have the same thing. So, I was going to try to put more space here, but I guess I can do it without it. So on this one, we're going to do 2/3 times both sides, because that's the reciprocal, and these cancel out. And that'll make it 4 pi over 9. And over here, we're going to do 2/3. I'll do it in a different color so it's easy to see. And the 2's and the 3's cancel out, giving me 8 pi over 9. And so I end up with an angle that's not on the unit circle because somebody has multiplied 3/2 times it and changed it into one that is, just like we've been doing with our double and half angles. So in this problem, I'm kind of on the same problem. I don't have anything outside the trig. Everything's inside the trig, so we have to get rid of the trig first. So that'll be tangent inverse of tangent theta over 2 plus pi over 3. Not only is this a half angle formula, but this half angle was shifted. And we're inversing the other side as well. And the reason we can do that again is because we know we're going to look up tangent in the proper quadrants, so these two tangents will cancel, leaving me the inside. And tangent is a positive in quadrant 1 and quadrant 3, and I'm looking for where they divided out the y by the x and it equals 1. So that has to be pi over 4 because that's where it's the square root of 2 over the square root of 2, which makes 1. And down here it has to be negative square root of 2 and negative square root of 2 that cancels to be 1 at 5 pi over 4. So I set those equal to my problem. I set up actually 2 separate problems because I have 2 different possibilities. And not always is there 2 possibilities. Sometimes there's only one if you're on an axis line and you're looking for something, but most answers have 2 possibilities. Now this one's going to be a little trickier because I don't have a common denominator thing going on. And I have 2 choices. I either get a common denominator or I multiply to get rid of the fractions altogether. I don't know which you might think is easier, so I tell you what I'll do. The first problem, I'll show it with common denominator, and the second problem, I'll show it with getting rid of the denominators, and that way maybe you can decide which way you like to do it better. Let me move this down. So if I'm going to get a common denominator, I'm going to change it to 12s. So to change this by 12s, I have to multiply by 6 on top and bottom. To change this by 12s, I have to multiply the top and bottom by 4. And to change this to 12ths, I have to multiply the top and bottom by 3. Now that I've got a common denominator, I can work the question. So I'm going to subtract 4 pi over 12 from both sides. Well, I still didn't move that problem forward enough, so let me put him over here. That's going to give me 6 theta over 12 equals negative pi over 12. Then you flip and multiply. And the 12s and the 6s on this side cancel, give me theta. And on this side, they cancel and give me negative pi over 6. So that is one way to do it. The other way, I think, might be better. I'm not sure. We'll move this problem up over here in this corner, and I'll show you how do you get rid of them. We did this back when we were doing rational functions. The common denominator is 12, so let's multiply the whole problem by 12. So 2 goes into 12 6 times, 3 goes into 12 4 times, and 4 goes into 12 3 times, and 3 times 5 is 15 pi. So you can see it got rid of everything. So you're just doing 12 times each one. It's like saying 12 times the first one, 12 times the second, 12 times the third. That's what distributing your 12 out does. So now I can subtract 4 pi and get 6 pi equals 11 pi, and divide by 6, and theta is equal to 11 pi over 6. Now, when we talked about domain with this question, we were talking about how in this particular problem, we were looking from 0 to 2 pi, and negative pi over 6 is not in that domain, so I throw that one out. Not only do I throw it out because of that, but it also happens to be the same angle as 11 pi over 6, so it's not like I need to write both answers for the same position. But I would really throw it out more because of the domain, because I don't need it, because it's outside the domain. In number 6, let's work this one backwards like we did earlier with substitution. We have this is our trig, so we're going to say 4x plus 6 equals negative 2, and solve that first. So I'll subtract 6. That's 4x equals negative 8, and divide by 4. X equals negative 2. Then I'll come back and set that back to my trig, because it would be easier to say cosine of negative 1/2. I'll flip it, and cosine happens to be that, we've already done this answer 3 or 4 times, at 2 pi over 3 and 4 pi over 3. So in this last question, let's try that substitution of trig again. So I'm going to take this piece out and put in x, because I think that'll make it look easier to solve. So I've got to get rid of adding, because you always get rid of adding first. And that gives me 3 square roots of 2x equals negative 3. Then I divide by 3 square roots of 2. And that gives me x equals, well, these 3's cancel. And that gives me negative 1 over the square root of 2. But I can't leave it like that. That doesn't look like anything on the unit circle. So I rationalize. Now I've got to put back my trig and look it up on the unit circle. So cosine is negative in quadrant 2 and 3. And for the first one to be negative square root of 2 over 2, I'm looking at the fourth lines of 5 pi over 4 and 3 pi over 4. So that will be my solutions. So it's just working it backwards and then looking up your trig. Hope this helps you, Daisy.